So section 2.4, the last section in chapter 2, is called the cosine law. So we just went over the sine law, and now we're going to go into its brother almost, which is called the cosine law. So what this video is going to talk about, it's not going to go over proof, okay, that's in your notes, but it's just going to solve some problems using the cosine law, and it's going to, of course, tell you what the cosine law is. And here we go. If you're given some kind of triangle, A, B, C, like this, the cosine law will give you the following equations. Okay, a squared equals b squared plus c squared. There you go. That's the Pythagorean theorem. But it's going to be minus 2bc cos a, so on and so forth. This does not have the limit of being a right triangle, right? This is any triangle. So just like in the sine law, it can be any triangle. That is why this is such a powerful law. The version or the variation of the cosine law that we're going to use will depend on the variables that we're looking for. So for instance, if we're looking for C, we're going to use this guy. If we're looking for A, we're going to use this guy. Sometimes we'll be solving for the angles. In that case, you can either rearrange this formula for one of the angles or plug in and solve for it. This is the proof for it. You can take a look at that. The first example we're going to go over is determining the length of an unknown side. Okay, so you can look at the example, take a look at the solution. I'll do the practice problem. If point C is 35.5 meters away from point A and 48.8 meters from B, and if the angle at C is 54 degrees, determine the distance AB to the nearest tenth of a meter. Okay, so let's draw some generic triangle. There we go. Okay, and let's say C is here, 54 degrees. It tells you that little c is, does it tell you what little c is? If point C is 35.5 meters away from point A, that gives you, in fact, that will give you side length of B, and it's 48.8 meters from B. That gives you side length A. And if the angle at C is 54, determine the distance AB. So we're actually looking for C. We're actually trying to solve for C because we're looking for this distance right here, that side. So clearly we're going to solve for C here, so we're looking for C squared. Now when you look back, C squared is equal to A squared plus B squared. Now how you're going to remember this, A plus B squared, that's Pythagorean theorem, minus 2AB, it's going to be the same values here. Order doesn't matter, but you can say AB cos of C, the only one that wasn't listed yet. So this is A squared plus B squared minus 2AB cos of the one guy you haven't listed yet, which is C. So this is a game of plug and play. C squared, and then here we go, plug and play here. A squared, what's that? 48.8. B, what's B? 35.5. And now we have the same values. A is 48.8. I'm running out of space, of course. This is classic. 35.5. Alright, you guys, I'm just going to write it underneath here. Cos of C, which is 54 degrees. That's multiplication there. That's not division. Highly confusing. But I think we're all on the same page. So, look at this computation we have to do. Let's do it. Okay. I haven't done it yet. I'm plugging them all in right now. Maybe I'll chunk it up for you. The first bit comes out to be that. Now we're going to go minus 2 times 48.8 times 35.5. And of course, you know, for sure chunk this up when you're doing it if that's what you're comfortable with. But the problem of chunking it up, of course, is that this happens. You're going to have a big decimal here, and the calculator probably cut off the decimal places. So what I would do is I would actually not clear your calculator if you're doing this and leave this in the answer function. Okay. And now go 3641.69 minus answer, which will come out to be, again, a very long decimal. I would not clear the calculator either at this point. Okay, I would take the square root of everything to give you your final answer of 40. We're looking for the nearest tenth of a meter, so that's one decimal place. And that's what it comes out to be. So don't worry too much about keeping all the precision here. But it's a good habit to get into. Okay, so that is how you solve for a side. Now let's solve for an angle. Just like in the sine function, we're going to go one and then the other. You can take a look at the solution here. Very lovely. But I'm going to do this question. A triangle, and that's supposed to say triangle, okay, triangle, has side lengths 14 meters, 18 meters, and 22 meters. Determine the measure of an angle of the angle opposite the 18 meter side to the nearest degree. Okay, so it gives you all the side lengths. So it makes it quite easy to draw. Okay, if you're given all the side lengths. So let's say we are given this guy right here. What's the longest side there? Probably him, and then him. And finally, this guy right there. We have to solve for everything else, which is kind of interesting. We should be able to find out what these angles are, right? In real life, if you had this measured out, you should be able to actually measure that angle. Okay, you can do this algebraically using the cosine law. And let's pick any angle you want here. You could solve for the whole triangle. We're looking for the angle opposite the 18 meter side. So we're specifically looking for this guy right here. For the sake of this, I'm just going to name these guys. Let's say that this is little a. That means this is big A. And let's say this is B. That means this is little b. And let's say this is little c. And so this is big C. Okay, that makes it a bit easier because we're actually looking for sine of A. So you can rearrange the formula, right? Here's one of the formulas right here. You could rearrange this for the angle, but you know what? I think that's just a bit more trouble than it's worth. I would just plug it right in. Okay, you can use c squared if you want. It really makes no difference. You know, if you get used to one, I apologize. What am I doing here? The way I labeled this, I'm sorry. The way I labeled this, I have to use a squared. B squared plus c squared minus 2bc cosine of a. Okay, that's what we're looking for. I would just plug everything in. A is 18, so it's going to be 18 squared. B is 14, it's 14 squared. C is 22 minus 2 times B, and B is 14. C, of course, is 22. Didn't learn from last time. Let's put this underneath cosine of A. So we should be able to simplify now and solve. So what we're left with is 324. I'm going to join these guys together. So we're going to have 14 squared plus 22 squared is 680. Then we're going to have minus 2 times 14 times 22 is going to be 616 cosine of A. Okay. I now can subtract 680 from both sides. Okay, to give me 324 minus 680. That will give me negative 356. And here we are. We're going to divide both sides by the constant value in front of cos A, and that will give us A is going to be equal to an ugly number, or cos of A is equal to an ugly number. So I'm going to actually take the inverse of this fraction. The negatives cancel, and so I should be able to do this. And I get an answer of 55 degrees. Hopefully you get the same. And hopefully I didn't make a mistake in my computations here. And that is angle A. Okay, angle A, which perhaps is a believable result right there. And that's all we're looking for. To find the other two sides, you'd have to do the exact same procedure for one of the other sides, but then use 180 minus, the sum of the interior angles of a triangle to find the last side. Which is how we're going to finish off this video, to solve an entire triangle. This is a great way to finish off the chapter. Given any triangle, and given the sufficient number of information, that is two sides and an angle, you perhaps can solve for everything, as long as in the ambiguous case, there is actually a solution. So, you can see I'm going to, I go through it in the examples. I do one particular example and I solve for everything down here. But I'm going to do this last one. In triangle ABC, A is 9, B is 7, angle C is 33.6. Sketch a diagram and determine the length of the unknown side and the measures of the unknown angle to the nearest tenth, i.e., solve the triangle. Okay. So, sketch a diagram. Well, sure, let's do that first. I'm really not sure what this solution will look like. I have no idea. All I know is I'm just going to sketch some kind of random diagram here. I'm not too worried about the accuracy of the diagram at all. I don't know what side C is. That much I can tell you. If this is A and this is B, then I can tell you that this is 9 and B is 7. Already my picture is pretty goofy. Okay, but again, don't worry about it. Now, what else do we know? We have to find everything from here. So, what can we do here? Well, we're going to have to use, let's use the cosine law to start off. And that's because we have one missing side. So this goes back to example 1. We can solve for this using the cosine law for the one missing side. We're looking for c squared, which will equal a squared plus b squared minus 2ab cosine of c. So c squared is going to equal 9 squared plus 7 squared minus 2 times 9 times 7 times cosine of 33.6 degrees. Now I'm simply going to plug that in. 9 squared plus 7 squared minus 2 times 9 times cos of 33.6 degrees. This is something we should be able to plug in all in one go and take in the square root. Gives you 10.7, which is roughly equal to 11. Okay, so c is roughly equal to 11. Now, given all the sides in one length, you really could do the cosine law again. But you know what? I prefer the sine law. Over here, in this previous example, I said, you know what, for demonstration purposes, I'll use the cosine law again to find an angle. But I prefer to use the sine law. Okay, you can use the sine law. That's what I said. And let's just do that. Okay, because the sine law states, and let's say we're going to go after, let's go after angle A. Sine of A is equal to that over, let's use what we found. Cosine of C over C. We don't know what sine of A is. We know what A is though. We know 33.6, and we also know we're all over 11. You can solve this, right? So that would be sine inverse 9 times cosine of 33.6 divided by 11, which is 43 degrees when you round it. There's another value. B is going to equal to 180 minus 43 minus 33.6 degrees. And this is really 43.0 actually, because we're going to take everything to one decimal place. So you're going to have 180 minus 43 minus 33.6. So B is going to equal to 103.4 degrees. That's 1, 2, 3. That's 1, 2, and 3. Missing pieces of information. All done and found. Just like that. So that is chapter 2. That is the cosine law. And this last question is using both the sine law and cosine law to solve a triangle.